So good afternoon and welcome back. We now want to look to one of the most common and growing trends in our local area networks, what we call the wireless LAN or wireless local area network. In fact, there's an entire certification. There's an entire certification on this. It's called HCIA WLAN or WLAN. HCIA WLAN. So this is one of the certifications that you can do to also complement the routing and switching certification that you already have for HCIA and what you're doing now for HCIP. So please consider that certification. So here we're just having an introduction. We're just having an introduction so that we can be able to understand the basics of the wireless local area network. Now, the wireless network technology, just like the internet and the network itself, was actually first developed in America. And the main purpose was for it to be used in households. Now, over the years, to be precise, over about 10 years, the wireless network technology has improved over various versions. This is normally worked on by a working group in the Internet Engineering Task Force, which is called the 802.11 Working Group. So they have continuously worked on this particular technology and improved it in terms of especially the transmission speeds. So when it first began in around 1997, you can see that it could only do a maximum of 2 megabits per second. But right now, the latest technology is 802.11 AC, which can do slightly above 1 gigabit per second. So really, wireless wireless local area network is an important part of our networks and can still be reliable in terms of the transmission speeds. Now, compared to its counterpart, which is the wired, the opposite of wireless, actually, you can think of it as the wired network. So compared to the wired network, the wireless network offers several advantages, one of them being mobility. Mobility means that users are not tied down to a particular access position like the wired network does. So you see, with a wired network, you have a port, as we saw yesterday, at a particular place, and which is maybe beside your working desk. But if you walk out of your desk, you cannot be able to access the network and the internet for that matter. So wireless networks provide mobility. They also provide flexibility because it is easy to deploy them anywhere. Just a moment. Okay. So with flexibility, we mean that for the wired network, sometimes it can be difficult to do cabling in some places or some scenarios. So for example, for home networks, if you've already built your house, doing cabling is not as flexible as just installing a wireless access point, which is going to cover your entire house. So wireless access is actually more flexible on that matter. The other one is on cost. So of course, this one is cheaper because when you think of the traditional wiring, you need to buy the cables, you need to involve an engineer who's going to, a professional who's supposed to do that, and it can be quite expensive compared to implementing a wireless network. Now, generally, With wireless networks, a single access point, so I'm talking of access point. Access point is an AP, which is a device that is able to offer you that wireless connectivity to the network. So a single wireless access point can range or provide connectivity to up to like 100 meters. Up to 100 meters. Now, other than these wireless technology, we also have other network technology, for example, Bluetooth, that is used for what is referred to as a wireless personal area network. What you use for your phone to share pictures with a friend or videos. So Bluetooth can cover up to a maximum of just 10 meters. Then we have WiMAX. WiMAX, on the other hand, is also a protocol that is worked on by IEEE. Yes, IEEE, a group called 802.16. And normally, this is the wider version of Wi-Fi. So whatever we are using here in our network is called Wi-Fi. WiMAX is the wider version, and it can cover up to 10 kilometers in terms of distance. And of course, we have the mobile data network, like the LTE, which is 4G network, really, GPRS, and so on and so forth. Now, again, as we've said, the main advantage of wireless networks is that they provide flexible network deployment, in fact, very quick network deployment, and they greatly also improve the work efficiency. So that is the introduction to this. Now, you can deploy Wi-Fi on your enterprise using one of two access points. One of them is called the FAT access point, and the other one is called a FIT access point. Now let's try and understand each one of them. Now, with a FAT access point, the access point really provides a complete protocol stack, and it runs independently. It runs independently. By talking of offering or providing a complete protocol stack, we mean it can be able to issue IP addresses to end users. It can be able to perform basic firewall configurations and also NATing. So it can be able to do everything on the IP protocol stack or layers. So that is what we call a FAT access point. Now, we've said that they run independently, and when it comes to manageability, again, you have to manage them separately. So if you have one FAT access point here and another access point here, then you have to configure each one of them separately. And all of them are going to offer the entire protocol stack to the users who connect to them. Now, the main disadvantage with deploying FAT access points is that they do not offer roaming. They do not offer roaming. Roaming means if this user moves from there to this room where we have this access point, then they'll have to reconnect again. They'll have to connect actually to this different access point. So they can't use, they can just move seamlessly from this access point to this access point and continue accessing the network or the internet for that matter. So users who move from one access point to another, they need to connect to that other access point again. So that's one of the challenges with deploying this independent FAT access point. Now, for that reason, FAT access points really apply to small-sized network, because if you deploy this in a very large-size network and you're having like 50 or even 100 access points, and all of them are independent, and you have to manage them separately, are you seeing the kind of workload? Then they're not also flexible because they don't support inter-access point roaming. So that's the main challenge with deploying FAT access point. Now, a better solution for large enterprises is what we call the FIT access point. Now, with a FIT access point, you can't use them alone. You need to use them with an access controller. You need to use them with an access controller. So the access controller really is the brain of these access points. So these ones do not have, they don't have, they do not provide the complete protocol stack, and they need to be used together with an access point. So a FIT access point can easily, it can easily be deployed and managed. Why? Because they are managed in a centralized manner. They are managed in a centralized manner. In fact, most FIT access points, you don't need to configure them at all. You simply need to connect them to your network. They'll automatically discover an access controller, and they're going to automatically again pick up the configurations from the access controller. So FIT access points, for that matter, support what we call zero-touch configuration. Zero-touch configuration, meaning once you deploy, you don't need to configure it at all. You will already have configured all the configurations here. So they are simply going to automatically discover the access controller and thereby be able to pick up the required configurations. Normally, they communicate with the access controller using what we call CAPWAP tunnel. When you get time, you can also research and read more about that. Now, one of the biggest advantages, and that's why it's mainly deployed in large-sized enterprises, is that these then supports roaming. Because if we're talking about passwords and SSIDs for these Wi-Fi networks, then you set them at the access controller. So once a user has that username or that particular password and they log in from one access point, if they move on to another, they don't need to reconnect again. They are simply going to be automatically connected. So this offers a fine-grained user management, quite easy. So for that matter, then we deploy this on large-sized networks. So please remember the difference between FIT and FAT APs. Okay. Sorry, I think I lost my network there a little bit. Hello, guys, are you able to hear me? Hello, can anyone hear me? Owen, John, can you hear me?
I'm getting you.
Okay.
I'm hearing you. I'm getting you.
What was the last thing I said? Are you able to see my screen now? Okay. Now, these are some of the Huawei wireless network products. They're very comprehensive and extensive, by the way. One of the best you can get in the markets. They offer so many features. So again, when you find time, you can go through them. Generally, when it comes to access points, we have access points that you can use within buildings, for example, within corridors, or even within a particular room. But we also have outdoor access points, which you can install, for example, at the stadium of the campus network, or at places where the students can simply chill and do their personal reading and research. So we have outdoor. And we also have access controllers that can be able to be used to manage fit access points. So these are some of the access controllers that you can also use. So when you get time, please have a look at that. Now, let's finish this up by looking at data center technologies. So data centers in an enterprise network, they provide an IP infrastructure for enterprises' key service systems. So they function as the core data management center for the enterprise. Now, generally, the internal servers of an enterprise are often installed in an equipment room or what we call a data center when it is large. Now, normally, a data center will have certain matching systems, which you can be able to see here. So, for example, we might have fire extinguishing systems, power and air conditioning systems, cooling systems, monitoring and management systems, and also equipment room cabinet and cabling systems. So this is just a layout of how this can look like. And it's normally a comprehensive solution that has all those things that I've just mentioned. Now, you need to understand that your network, your local area network is part of the enterprise data center. So these are not separate. They're not separate things, but during the network implementation project, you need to take care of this particular module, the data center module. Now, you can implement your data center in one of two ways. You can either use the traditional data center network architecture. When you do that, then we are simply using the 3-layer architecture. So the characteristics of data centers that can use this ones that have a small geographical scope. They still need high bandwidth requirement and also high reliability. So this structure is similar to that of a campus network. So traditional routing and switching technologies and on-demand layering. So you simply can use the 3-layered architecture, or you can just have 2 layers. Now, generally, with data centers, you need high performance switches. Most likely, they might be the modular switches and not the fixed switches. High bandwidth interfaces, and you should be using the optical links. You also need redundancy strategies such as stacking for device redundancy and also multi-link for link redundancy. So those are some of the requirements really for a data center. Now, you might also implement the new 2-layer or flattened network architecture, and you might use, for redundancy, you might use this technology called TRILL. TRILL is transparent. Remember, yesterday I had forgotten what TRILL means. So it is transparent interconnection of lots of link. So this is a layer 2 technology. TRILL is a layer 2 network technology that was created by IETF. So normally it's used to resolve the issue of multipath on large networks and is normally applicable in data centers. So really, with TRILL, it supports non-blocking links. So you don't have to block other links. For example, you see, when we're using the other three-layered architecture, at layer 2, we have to, at the access layer, we have to deploy STP to avoid loops when you have redundancy. But when you have a flattened network like this, we really do not require to do that, so that we don't block other links. Because when we block links, we are wasting those links because they are not in use. So we are wasting bandwidth. So TRILL also supports what we call the equal cost multipath to ensure load balancing between the links. It also supports fast convergence of the network, and it supports large layer 2 networks. So problems of the traditional network, the one that we just saw, is that some links are blocked, and this leads to low utilization, and you cannot be able to do load balancing. It also has slow convergence. For example, when STP when STP goes down, or a link goes down, then it has to follow that particular protocol's algorithm before it can converge again. And the architecture is also quite complex, especially when the network nodes increase. So the architecture becomes more complex, and it offers actually low forwarding efficiency because you have to pass through those three layers. So the new requirements for a data center, normally they are large scale, and we want high performance in terms of forwarding data and also processing the data. And the other thing is it requires things like virtualization, so that and virtualization now demands what we call migration. You can be able to migrate a virtual machine from one machine to another without affecting the layer 3. The layer 3 or layer 2 configurations of that particular virtual machine. So really, this is the current architecture that is used in most data centers. Now, another technology that is currently being used in data centers is what we call FCoE, or fiber channel over Ethernet. Okay, so let's first of all look at the traditional data center architecture, and then I'll explain about that. So traditional data center architecture. Now, normally, this is divided into three layers. Here we have the front end of the network. Here we have the back end. And in the middle, we have the servers. Now, the front end is simply your local area network. The purpose is to offer high speed forwarding and processing of data. So here we have the routers that are needed to do exactly that. Now, these routers are directly connected to our servers. Now, our servers on the other end are connected to the backend, and the backend is the SAN, or the storage area network. So it is on the storage area network where we have our storage devices. So these are our storage devices. So really, this is what we have in the traditional data center architecture. Now, what are some of the problems with this? So complex networks, independently deployed LAN and SAN. You see they are on different layers. and they are independent. So data has to come from the top to the processing, then down, or from the storage to the server, then out of our network. So this also is not very energy efficient, uses a lot of power, and you'll need multiple interface cards. You'll need multiple interface cards. You see, each server must have at least 4 to 6 interfaces, because you need at least 2 interfaces in order to ensure redundancy to connect to the LAN, and you'll need at least 2 interfaces in order to connect to the SAN. So multiple interface cards. So that's the problem with the traditional architecture. Now, the improvement is what we're seeing here. It's called the converged network architecture. Converging in technology simply means you're combining things into a single device. So here, what we're simply doing is changing this architecture to this, so that we have the server cluster and the storage system at the same level. So we simply have our LAN here. Then we have the interconnection between the servers and the storage at the same level. So you see, with this, we are able to, for example, solve the issue with multiple interface cards. Now the server can have lesser. In terms of energy and equipment, we also eliminate some of the equipment, for example, that we were using to interconnect the storage devices. So this offers simplified networks, LAN or SAN convergence, and it also reduces the total cost of ownership because it's more energy efficient. And we have a single converged network adapter, or CNA. Now, the purpose of fiber channel over Ethernet is to implement the convergence of the storage area network and the data network. So that is the purpose. So this ensures that we have high bandwidth communication between the servers and the storage devices. We have low delays, and we also have no packet loss during this communication. Now, generally, Huawei data center switches support FCoE technology. So they actually support fiber channel over Ethernet technology. So virtualization is another growing trend in data centers. Virtualization, generally problems with the current networks is, for example, the investment costs and the resource utilization was not very efficient, meaning that, for example, you have to implement your own server, your own data center, your own network, your own cooling system, your own power, personnel. So the investment cost is too high for the traditional networks, and you're not going to be using that particular resource, that particular server, 100%. So the resource utilization is also poor when you deploy such data centers. Sometimes it can also be the operational maintenance can also get complex depending on how big your data center is, and you also have to take care of things like security. Now, instead of deploying, for example, your own data center, you can go to the cloud, for example, so that you can be able to share a single device, and you can be able to share with others. So that is what we call virtualization, where a single physical device is simply shared between several users, and each one has an instance of that particular device depending on their requirement. So some of the common solutions of virtualization is device virtualization, where we virtualize a device. We also have service virtualization, where we virtualize protocols such as STP, channel virtualization, where we virtualize, for example, layer 3 VPNs, and so on and so forth. So when you get time, also read more about virtualization. So we also looked at VXLAN in the previous module, virtual extensible local area networks. One of the challenges that is brought about by virtualization is sometimes you want to move a virtual machine from one server to another server. Now, you see, here we are having to cross from a layer 2 network all through to a layer 3 network. So when this happens, then it means that this virtual machine, we need to change some configuration like the IP addressing and so on and so forth, which can be quite a huge workload depending on the number of customers we have. So VXLAN is used to enable us actually to be able to do such like migrations seamlessly. And when you're doing so, because we won't be able to change so much configuration, it will ensure service continuity. So VXLAN solution really, it ensures that we have reachable IP routes through equal cost multipath. VXLAN also, unlike the normal VLAN, which provides a VLAN ID with 12 bits and therefore provides around 4096 VLANs, this one uses 24 bits for its VNI. So it offers around 16 million virtual networks. VXLAN also provides fast convergence, loop prevention, and flexible deployment. So VXLAN encapsulate layer 2 data packets into UDP packets, and they provide technologies over IP networks. So normally, in order to ensure that we have migration, easy migration and service continuity, we deploy VXLAN. We've also looked at the concept of SDN in the previous module. An SDN is used to provide unified network control in order to simplify network device management and flexibly schedule traffic. Now, in the traditional network, you have the control panel and the data panel in a single device. So everyone does their calculation of the efficient path, and everyone makes their own decision. But now, with SDN, we want to take the control from the devices so that we can have a centralized controller. So the good thing with having a central controller is that it has an entire view of the network, and therefore you can be able to do better dynamic traffic engineering in order to select the optimal paths. So one of the SDN solutions is provided by ITF, provides an intelligent panel, smooth evolution of network architecture, the standards it uses to facilitate communication between the controller and the network devices include SNMP and also net config. So most traditional network device vendors actually use this IETF solution. We also have another SDN solution called ONF. So again, I give you that as a reading assignment. When you get time, please find out more about ONF solution. These are some of the Huawei data center switches. So normally they provide high density gigabit access that support up to 40 gigabit Ethernet uplinks. So when you get time, please go through this. So a case study, a university plans to construct a central equipment room where all college servers, about 1,000, are centralized for unified management. So the number of servers will increase in the future. How is the network? How is the network in the equipment room designed? How is the network in the equipment room designed? So make time. We're just about to end this. Make time so that you go through this particular scenario. Okay, so network management. Let's look at network management. I think this is the last one. So network management, we know that as the network grows, it can be difficult to monitor the network, to test the network, to configure the network, to analyze, evaluate, and control network resources. So all these components are the components of network management. Now, network devices can be managed either, not really, but it can be managed through the interface, and normally it's through a particular data channel. So the data channel can be in band or out of band. Now, when we talk of in band, we mean that you've directly connected to that particular device. When you talk of out of band, we mean that you're connecting to that device remotely. You're connecting remotely. So that is what we call out of band management. In band, you've connected directly, for example, through a console cable. You're configuring it directly. So that is what we call the data channel. Now, once you connect either in band or out of band, you're going to get an interface through which you're going to do the configuration. The interface might be character-based user interface, like a command prompt, or you can get or use a graphical user interface. So command prompt, such as the console interface when you're connected through a console cable, or telnet interface or SSH interface when you're connecting remotely. Then graphical user interfaces simply use SNMP and HTTP to connect. Now, the current network management system is normally SNMP based GUI management software. So normally they use SNMP and they offer graphical user interface. So this is not supposed to be V, it's supposed to be NMS, network management system. Okay, and this is what we just said. So again, we know how SNMP works. So you as the network admin, you can be able to, no, this is your network user, then you're the network admin here. So you have the network management system. So you can be able to connect remotely to any device. That device is normally called the managed system. The managed system runs an agent which can be able to interact with MIB, or management information base. All this is achieved through the protocol, simple network management protocol. Huawei offers an NMS by the name of eSight. eSight is a very comprehensive NMS that can be able to achieve all these functionalities. I think we already looked at this in the previous module, so I'm not going to go through it again. We know that we have 3 editions of eSight: the compact edition, standard edition, and professional edition. Again, depending on the number of nodes that you want to monitor and manage, you should consider either of them by also considering the function, the market. For example, compact edition is for small sized, while this one is for super large networks. Also, the storage capacity is important. You look like the number of alarms. All of them can offer up to 20,000. You look at number of historical alarms that they can store, all of them, number of logs that they can store, and also the number of performance records. So you can see, for example, compact edition does not offer historical alarms and performance records. So it really depends with what you want. So configure an NMS for a campus network. So you can deploy eSight for your campus network. Should be able to cater for that. So let's finish up by looking at the overall technological solution. Now, at the end of the network design phase, you will need to come up with a technological solution for the entire project. So normally, this is considered as a milestone that you've completed, because now you've completed the network planning and network design phase. So this is the boundary between the early planning and design stage and the later implementation stage of a project. So it's actually a milestone. Now, you'll need to come up with a summary of the planning and design stage. You must come up with a summary of the planning and design stage. And these will include what we call the project baseline. So that is the objectives of the later implementation stage, including a comprehensive technological solution and the implementation details of the project. So really, the project technological solution is considered as the most important part of a bidding document. So this documentation is considered as the most important part of a bidding document. And sometimes it's actually what might guarantee you to win a bid or to lose it. Now, these are some of the content. These are some of the content of the technological solution. So really, the technological solution contains all the achievements in the project planning and design stage. So you see here, this is what we get after the planning stage. So the project background and the requirement that the user wants. Now during the design phase, we do this. Number one, we look at the detailed technological solution. So it is what we've just covered in the preceding topics. So you look at the topology, the physical network topology design. So you have to do all this, the logical network design, etc., etc. Then you also need to have the relevant engineering problems in terms of the technological equipment that are needed, the schedule for implementing each phase of the project, and also the engineering team and personnel that is needed or that you're using to implement this particular project. So when it comes to the personnel organization, you have to, for example, present the academic qualifications and certifications of those personnel. So going forward, when you get this certification, I'm sure some network companies are going to be approaching you so that you partner with them when they are bidding, so that they can, for example, use your certificate and maybe also use you after they win the bid. So that is one of the most relevant documentations that are required during the bidding process. Okay, then lastly, you might also provide the device purchasing list. So the device purchasing list really includes all the network devices that are needed and any other materials that are needed, for example, for the line or the links. But it does not include the quotations. It does not include the prices of that particular device, just the devices that are needed. So that is what the device purchase list contains. Okay, so these are some of the relevant files that we must have after the design phase. One of them is the commercial paper. So the commercial paper will include the engineering quotation, the responsibilities and obligations of each party. That means the customer together with the engineering team, and also the disclaimers where we put the legal matters that are going to guide the project, including clauses about the force majeure. You also need an authorization profile. So this is attained from the project design partners. You also need the certifications. So your company certification, for example, that mandate you to run such a project, and also the personnel qualification, certificates for your personnel, and other related documents. So if you read the notes, you're going to see some of the other related documents that you need for this. So ladies and gentlemen, that is the end of this long chapter on network design. I'm sure it was long but interesting and also eye-opening. I hope you've learned a lot. Anyone with a question, comment? If not, can I have a volunteer to help us with the first question? Okay, thank you very much. Asanteni sana for your patience. We meet again for the next chapter. Thank you.